No. Position factory to avoid writing new position everywhere. Okay, so this returns, or like adds on to this thing, squares relative to our position. This is gonna give us back some errors though. But let's take that when we get to it, because it's gonna give us, try to get squares at positions that don't exist. And we need to do index, index plus plus. And return squares. So let's check the test now. Index -4 out of bounds. Yeah. So we need to add a function to test if the square exists. Or like is valid position or something. So let's create a new test. Void is test is valid position. And then board equals new board. And then we just want to do assert false. Board dot is valid position. New position is valid square position. Square position, new position, and then like -1, 0 should give us false. Create this method. And we have the bounds here, width and height. Return. We can store the positions. No, let's just do get x and get y. So position dot get x needs to be above -1, and position dot get x needs to be below this dot width, and same for y, but with the height. So what if we test this? Oh, at test. Should have made it fail first. Let's do that. Return null. Return false. Return true. unreachable statement. Yeah. And now I want to try like below bounds and over bounds. So I want to try both in this test. My internet is being so trash right now. Really? Assert false board.is valid square position, new position in like 4-1 should also be out of bounds. And assert true board.is valid square position, new position 1-1. And I want to try the same here, but like with the y-axis being out of bounds. So 1, 1, but -1 and 4. Cool. Working on the Blender stuff right now, but I forgot to send that repo to you. Oh yeah, cool, cool man. Would be interesting to explore it while I learn Rust and stuff. You would like it. Right now I'm making geospatial stuff. Can also help with Rust and math. Yeah, thanks man. Thank you so much. Okay, so test is valid position is now done. So get neighbors. We can go back to get neighbors. So we need to also check that this thing is a valid position. So and is valid square position. We should probably not calculate this twice. So let's do int x equals position dot get x plus So this is the relative x, this is the absolute x. Get x plus absolute x. Not absolute, what is it called? Nominal. Thank you for the follow, Fantasy. I don't know if it's a good idea to use my low latency C stuff for this, because possible errors. Okay. The first set of types are point, vector, matrix, and quaternion. You mean for like math? Point, vector. What's the difference between a point and a vector? Send a snippet in DC. Oh, thank you. So absolute Y and Y. And here we can just do, since we already calculated that, absolute X and oh, a point is a scalar generally. Got it. And a vector is two scalars. But I guess a vector could also be, that's something I learned yesterday. There's like a, what is it called? Something on C. Not Euclidean, but like a vector where you have like an X and a Y, but there's also a polar vector where you just have an angle and a length towards that angle, or like a yeah, the length in that angle. No, not rank. Bisect. Point is a scalar generally. An object with coordinates x, y, z. Vector is expanded on 2D, yeah. What was it called? It was like polar vector and Cartesian. Cartesian. So xy is a Cartesian, but then you have the, so like if you have Cartesian with radians, yep. So if you have like this and you have this point here, this would be x and this would be y. So let's say, okay, this is a bad example, but like 2 and 3. So then you could write 2, 3 to define this point, or to denominate this point. But you could also write, I don't know on top of my head now what this would be, but it's 2, 3 squared, so it's 4 plus 9, the square root of 13 here. And then a certain angle. So you could also write it as a square root of 13 and the angle to denote the same point. Haven't worked with radians like sophomore year or high school. Theta, yeah. And like this combination, it's the same information as this. It's a point in space. My favorite shit, yeah. Like pi square root 3 and 3 divided by 2 or whatever, yeah. WAs for aeronautical was the slip angle. If you have an airfoil. What's WA? How much friction you can generate may not be enough to stop. Oh yeah. Yeah. Yeah, I remember that from physics, like the friction calculation. It was something like that. The more power you put on it, and then like it falls down because you start drifting. Slip, yaw and ditch. Aerodynamics. Aircraft is moving somewhat sideways as well as forward relative to the oncoming airflow. Relative wind. For a conventional aircraft, the nose will be pointing in the opposite direction of the bank of the wings. The aircraft is not in coordinated flight and therefore is flying inefficiently. Ah. Inexperienced or inattentive. I guess this is very difficult to avoid though. Like you can't control where the wind is coming from. Aerodynamics had a lot of calculus. Also because the concept of downforce for cars, it's easier to imagine because everyone drives. Interesting. Is valid square position. Position. I'm kind of expecting this to pass now. Actually. No? -4 out of bounds. Hmm. Wait, why? How do we get to that? Board. Get square at position. It shouldn't move here if it is a valid. If it is an invalid. Oh, wait a minute. Yeah, we don't use position here. This is always returning true. A new position. Absolute X, absolute Y. This should work. Okay. So this comparison is failing. Downforce and slip angle. Love that shit because for us, we have Newtonian physics. So if you can't apply enough force to stop, you'll just go wee and slide in whatever angle is having the least friction. Ah. Because tires can only generate so much and cars are heavy. Hmm. Yeah, that's interesting stuff. It's all enabled for us to calculate because of linear algebra, I guess. So if you have 100 kilos in y and x direction, you can use Pythagorean. It's that easy, yeah. I wonder if at his time Pythagoras knew, or of course he didn't know, but like what he would think if he knew how important his theorem has become for like everything we do. Like the more I learn about trigonometry and linear algebra, it's like it's everywhere. It's the basis for, like, let's say computer graphics seems to be without that, I don't know if it would work. Based on my current knowledge, that's That's my view. This is more physics and calculus technically, but you can represent the weight in each part of the car. Nice. So what am I actually getting here? I want to debug this. The hardest balance is, in my opinion, stochastic, an unsolvable random variable, if you want to interpolate and basically pathfind on a mutable surface. What do you mean? Can you give some more context or like an example? What? What happened now? Allow. Squares. Okay, there's one square. And correct squares. There's 3. So why was there only one? Print system.out.print squares. System.out.print correct squares. It doesn't even go there. It doesn't print it very well. If you want to pathfind, what do you give up, accuracy or precision? Yeah, so imagine we have a stock market where people buy at random intervals. Try and predict what the price will be in a year. You have 0 confidence. But now you have it. So what is the amount of randomness in the system where you start to lose most of your approximation? And what mechanics make that decay faster or slower? Interesting. You're making a funnel. But how do you test this? How do you know if you're right or wrong about your probabilities? You can't really prove it, right? Because if something happens, you don't know how likely it was. You can do hypothesis testing. So this is only giving me 1 square. The 19291 one. So why only 1? And give confidence intervals, which is, this is what I said about consistency. True. Have you read any books by Nassim Nicholas Taleb? He has a pretty good one called or he has written many good books. I've only read one of them, but it's called The Black Swan. It's a bit about this, like, and a bit of what you alluded to earlier when we talked, like this normal distribution, that there's a lot that points towards the normal distribution not being that applicable in these like extreme environments. So maybe it's applicable like when you compare people and like how tall they are in a population. Then maybe you can use normal distribution to find the probability of someone being at a certain height. But more events that are more extreme and more unpredictable, or like more that don't behave in a normal distribution way, are a lot harder to predict, and something like that. Yeah, he's your favorite. Nice. Tricked by Randomness is a good book too. Yeah, normally it was assumed more data makes it the bell curve, makes it fit the bell curve. Yeah. I started reading about, there's this guy called Mandelbrot who has some kind of Mandelbrot distribution or something. And Nassim Nicholas Taleb apparently likes his work. Cauchy distribution. Dude, you know so much. Makes no sense because it doesn't have moments. No variance, skew, or kurtosis. Okay. So when you have two normal distributions together. Okay. And is valid square position, squares index, get square at position, index plus plus. And then proceed. Why is it not working? Mandelbrot was good at math only. Got it. Fractal market hypothesis. Interesting. I'll have a read on that later. Thank you. Doesn't even come close to capturing tail events. Tail events get fractorial in their chaos, where normal distribution is exponential. So you need something like a gamma or Pareto, etc. I love this discussion. Let's put the debugger here. I'm expecting it to land there 3 times. Okay, so 1, 1. Ah, I get why this is not working now. It stepped into 1, 1 because it doesn't allow 0. But we don't allow them to be 0 at the same time. That's the thing. How do I check that? It's my specialty. Thank you for appreciating how much time I spent studying this. Now I can teach you all the secrets. Yeah. Thanks, dude. Oops. So, this is a problem that needs to be solved. So 0, 1 needs to be okay. It's like not... Let's just say it in normal language here. You know it like the back of your hand at some point. That's amazing, dude. That's the goal. So we don't want x to be 0 and y to be 0 at the same time. So now if this is 0 and this is 1, this is going to return false and then be converted to true. But if both are 0, it will be true and then that will return false. I think that was the bug. Yes! It worked. No, not necessarily. Wait a minute. Let's do a debug. I want to inspect it. Okay, it's failing. So let's do a debug. Squares. Correct squares. Okay, now we have 3. 19, 30, 28, 29. 28, 29, 30. So we have all of them now. It's just a matter of figuring out the equality now. Oh, nice, man. Yeah. You should do what you're passionate about and what you enjoy doing the most. And seems like you are. I think it both makes you happier and better at what you do. Search, no, Java equality between two unordered arrays. Their contents, the array equals static method. Iterate per position. Yeah, that's not what I want. because they're unordered. This, yeah, we'll get different results. Using simple types. So what is deep equals? Is that what we need, maybe? The predictors. All these chaos theory guys came in, and now more physics PhDs are there than academia. Ah. Interesting. Are equal or not. Correct squares dot deep equals, but it doesn't even have that method. Deep equals. Deep equals hash, yeah, might be. So that's not what I need then. Okay, so let's first then check if they are the same length. Dot length equals, no, assert equals, so correct, no, squares dot length equals. So we have to write this ourselves then. What happened? It's lagging. So that worked. Unordered array Java. Oh, can I do sort? Thanks for streaming, man. It's so boring around this time EST. Yeah, thanks for hanging out in the chat. It's been a lot of fun. Made me use my brain and recall a lot I sort of forgot. Nice. Yeah. Cold storaged it. Yeah, exactly. So let's try this. Assert equals squares dot sort. So there is no sort. Oh, arrays dot sort. Sort. Sure, let's import that. arrays dot sort and squares and arrays dot sort correct squares and squares.